we're going to look at how to make qualitative kinematics graphs, particularly in the case where we have piecewise constant acceleration. So what that means basically is that the acceleration is going to be constant for a period of time, then it might change to a new constant for a period of time, and then it might keep doing that. But it's not going to be continuously changing. The acceleration graph isn't going to look like a line with a slope. It's not going to look like a curve. When that happens, the graphs are only going to have certain shapes available to them. The acceleration graph will be a flat line, maybe changing to a new flat line. The velocity graph is going to be a line with a slope, either positive or negative, or it could be a flat line with zero slope. And then the position graph could be a flat line with zero slope, a line with a positive or negative slope, or it could be a piece of a parabola. And basically, I've sort of sketched these out. It could be the piece with positive curvature going up, the piece with positive curvature coming down, the piece with negative curvature going up, and the piece with negative curvature going down. And you can see how you put these together to make different parts of the parabola, but what's important is that you can see in particular here that this is, if this were a position graph, as time moves towards the right, this position graph is moving downward, but it's slowing down. And we'll talk about that as we go through some examples. In this assignment, you can find the link if you're in my class on the Canvas site. If you're not in my class, I'll provide a link below and you can click on it. When you're looking through this assignment, in each case, one of the graphs will be given, and it's up to you to come up with what the other graphs are going to look like. So we'll go through a couple of examples here real quick. The way this works is when you double click on it, it will open a Google Drawing window, and then you can pick each of these elements, and then you can press Control D to duplicate that element, and then you can drag it and use it wherever you want. So for the velocity, how do we get the velocity? Well, we know that velocity is the slope of the position graph. That's a positive constant slope. So we're going to change our slope, or we're going to change our velocity graph to be a constant positive value. How do we make an acceleration graph? Well, acceleration is the slope of the velocity graph. That slope is 0. So we're going to get a constant 0. And we'll skip a couple here. We'll come down to this one. Now, these curves are not perfect because I was just trying to use them with the curve tools. This is meant to represent a piece of a parabola. Whenever you see the curves, we're only dealing with pieces of parabolas in this class because those are what you get when you have a constant acceleration. So here you see a parabola going up and curving up. So first let's think about what this means for a position graph, right? That means that we're moving in the positive direction. Maybe that means to the right if you have an axis that's going left-right. Maybe that means up if you have an axis that's going up-down, or whatever positive means in your coordinate system. So I'll just say right. This object is moving towards the right, and it's speeding up. How do we know it's speeding up? Because the slope keeps on increasing. How do we know it's speeding up? Because how do we know it's speeding up? Because the slope keeps getting steeper right? Not just that the slope is increasing, because the slope could be sloping up or sloping down, but that it keeps getting steeper, meaning that it's covering more ground in each little interval of time. So how can we represent that down here in the velocity? Well, we're going to get our velocity line, we're going to put it down here. We want to make sure we're going in the positive direction, so that means that on our graph, all of the velocity is going to be on the positive side, this positive half. So if I were to draw a little box, everything positive is on this side. But we also have to represent that it's speeding up. How do you know when the velocity graph is speeding up? The values are farther away from 0, right? Because 0 is the slowest you can go. And if I were to make up numbers here, I could say that maybe this is 5 meters per second, and maybe this is 10 meters per second, right? So if you're starting at 0 and you're going to larger and larger magnitude values, then you must be speeding up. How do we get the acceleration graph? Acceleration is the slope of the velocity, and that slope is a constant positive value. So we will come up here and put it there and make it some constant positive value. And notice here, I made up these numbers, right? I don't know if it's 5 and 10. I don't know what this numerical value is for the acceleration. That's what qualitative means. It's without numbers, it's just the shape of these. Let's do another one here. We'll do the one right below it. Let's think first about what this position graph means. First, we're starting at a large positive value and moving towards 0. Maybe that means this object is starting on the right-hand side and moving towards the center. So that means it's moving towards the left. Right? Is it speeding up, slowing down, or going at constant speed? Well, the graph is getting steeper for position, right? So that means in each little interval of time, it's covering more and more ground, so this must be getting faster. How do we make a velocity graph for that? Well, we know we're going in the negative direction, so that means that we need this side of the velocity graph. Everything below the axis on the velocity graph means that we're going in the negative direction. So we're going to put our velocity line somewhere in the negative, and it needs to be going faster. So our line is going to point down like that. Why does that mean we're going faster? Well, kind of like before, this first line, I'm making up numbers again, but maybe this first line is at -5, and the next line maybe is at -10 meters per second. And so as you get farther and farther from 0, you're going a larger magnitude, but in the negative direction, which maybe means to the left. So you must be going faster and faster. How do we get the acceleration graph? Well, we need the slope of the velocity that has a constant negative slope. So we'll put the acceleration as a constant and negative. As we proceed, we can see that we get to a section where there are now changes in the shape of the graph between the first half and the second half. So let's do this one. So in the first half of the graph, the object is moving toward the positive direction. We'll say that's right. The object is moving to the right, but it has a constant slope, so it must be moving at a constant speed in the right direction. And then the slope is beginning to decrease as it continues to move in the right direction. The slope is getting shallower in the right direction. So, my line is gone. We'll make a new one. So, what do we need? This is how you can make the line bigger again. First, we need a positive velocity that's pointing to the right. So for the first two tick marks, we need that. And then for the second part, since the slope is becoming shallower, it needs to be going slower, right? But it still needs to be positive. So how do we indicate that with velocity? Well, it needs to be on the positive side, but it needs to be going toward 0. Because as you start with a positive velocity, you can get closer to 0. That's going to be slowing down. Or even if you were to start with a negative velocity and get closer to 0, you would be slowing down. Finally, we need an acceleration graph. We need the slope of velocity to get acceleration. This has a constant 0 slope for the first two tick marks. And then for the second two tick marks, we see we have a constant negative slope. So we'll just get our line and make it a constant negative. Now, I am personally not too picky about what you do with that jump discontinuity. Trying to make it line up better. You could put a vertical dashed line. You could do open circles. Any of those things you've learned in math class to indicate a jump discontinuity are fine. I'm just going to leave it empty right there. Okay. Now, as we proceed, we'll get into a section where the velocity graph is given, but the acceleration graph and the position graphs are not. So there are two things we need to note here. The first is that if the velocity graph starts at a given value, that does not tell you where the position starts. The position graph could start at the -2 tick mark and do whatever it needs to do and give you the same velocity graph as if it started at the +2 tick mark, right? Because it's only the slope of the position graph that gives you the velocity graph. So you can start anywhere you like and get the correct answer. But it pays to pay attention and plan ahead a little bit just so you get a nice looking graph. I like to do the acceleration graph first because it's very straightforward. It's the same thing we've been doing. Take the slope of the velocity graph and you get a constant 0. So we'll just do that real quick. Okay. We need to come up with a position graph that will give us a constant positive. Well, a constant positive slope means that the position graph is, mess that up, a line with a constant positive slope, right? So there you go. What's one? Here's one that's a little different than we've done before. So now we have a velocity graph that's going in the negative direction and is getting farther away from 0. So how would we describe that motion? It's going to the left or downward, whatever our coordinate system is, and it is speeding up because it's getting farther from 0. We'll do our acceleration graph first. So we need a constant negative value. And we'll do our position graph. We want a position graph that is moving, we'll say downward. We'll say that's our negative direction. But it also needs to be speeding up. Speeding up means a steeper graph. So we have these 4 choices. we need it to be moving downward as you go to the right. There's only two that do that, this one and this one. And it needs to be getting steeper. So between these two, this one is the one that's getting steeper. So we will put that over here. And then there's some fiddly things with Google Drawing, trying to get that to fit over here. And, you know, is that exactly what we'd want it to look like? Maybe not exactly, but it's got the right general idea. Okay, let's skip way down. Let's look at this example next. We're going to look at the velocity graph and we're going to divide it into two halves. Let's look at the first half first, and let's look at the motion during this first half. So what direction is it going first? So remember, anytime the velocity is on the top half, we're going in the positive direction. Let's say that's upward. So if the velocity is above the axis, we're going upward, and if the velocity is going below the axis, we're going downward. So where are we going in the first two tick marks? We're going upward. What's happening to the speed as we're going upward? Well, we start with a large positive value, and we're going towards 0. So we must be slowing down. And then there's a little an instantaneous amount of time that we hit 0. And then after that, we're in the below the axis portion of velocity, so we're going downward. And velocity is moving away from the axis, so we must be speeding up. Does all of that sound like something you're familiar with? Move up, slow down, stop, come down, speed up? Maybe. Maybe you've seen something do that. All right. So what does that acceleration look like? Well, for the first half, we need the slope of velocity graph. So that looks like a constant negative value to me. Second half, we need the slope of the velocity graph. That looks like a constant negative value to me. And in that middle part, we need the slope of the velocity graph. That looks like the same constant negative value to me. The acceleration has that same constant negative value the entire time. What does the position graph look like? For the first half, we need moving upward but slowing down. So which of these graphs move upward as you move to the right? That one and that one. But which one slows down? So we need a flattening slope. That one gets steeper, that one gets flatter. So we need that one for the first two tick marks. For the second half, we need one that's moving downward, but is getting steeper. These two move downward. That one's getting shallower, flatter. This one's getting steeper. So we need that one. So we put those two together, and you can fill with the boxes and everything, but there we go. So the position graph looks like a parabola that's pointing downwards. Okay, so you now know enough to complete this assignment, and I will have the key up. I will link that as well for practice assignment for my students, or just to practice on your own if you have happened to stumble across this video.